All right, so recording has started. Thank you everyone for joining this August batch. And as I have been saying, sending a lot of reminders. This is mainly focused on Kubernetes, very key subject that is being discussed in the interviews. There used to be a meme floating around which would say that Kubernetes used to be a topic which gets discussed in the interview, but hardly used in the environment. I'm not sure if you got it. So they will ask a lot of, I'm talking about like 1 year, 2 years ago, a lot of questions about Kubernetes and how containers interact with each other and a lot of networking related stuff. But the actual work never used to involve that kind of thing. Because it was being used for a lot of non-dev environments and non-production environments. But of late, a lot of companies have started using Kubernetes platform, and now it's actually discussed in the interviews in more detail. People or the person who is taking the interview understands further details about it, and they expect quality answer as well. So we'll start with the sort of presentation first. Usually, like if there is a meeting of this sort, we'll go with a sort of round of introduction, but with such a massive arrangement, it's not possible to have individual introductions. So we will jump on to the main material straight away. And before we get into that, is audio, video, everything fine with everyone now? Cool.
Yes.
Yes.
So welcome to the new people who have just joined. My name is Sanjeev. You guys know me already. You have been watching our YouTube channel, and I have been joined by Saurabh Porwal as well, who is my partner, and he will be helping us in the future sessions and future projects, and a lot of content he has started delivering. So we are based out of Australia, and I am a cloud and DevOps and cloud architect by profession, and I have around 21 years of experience in the industry. So I'm creating these projects to bring my knowledge that I have, try to simplify that into small projects so that you get that industry knowledge, the terminology that people speak in the professional world. The objective is to bring that knowledge to everyone, which is where I can reach out to. So let me share my screen. Is it visible, the screen share?
Yes, sir.
Yes, it's visible.
All right. So this is the first session. So hold on to the questions that you may have. I will try to answer most of the questions in the presentation today. This is more of me presenting to you the project requirements. You can treat it as your customer sending you the requirements, or your architect or your team lead giving you the requirements that they have received. So take it that sort of session, and hold on to the questions, because I'll come to where the recordings will be posted, where the PDF will be provided, when the next sessions are going to happen. So hold on to those questions. We will have time in the middle of the sessions and a lot of time at the end of the session, where we can take individual questions from everyone. Have a pen and paper if you want to. If you have some urgent question, note it down. I won't be able to follow chat in real time. You can post there, but we'll pick it up towards the end. All right. So we will, before we get on to the project specifications, just to acknowledge that why we are doing this project. So I have done a similar sort of 10 minutes talk in my previous July batch as well. So that link is here. You can watch that also. So basically, we want to highlight, or I have been saying on the channel as well, why we are doing these kind of projects. We need to acknowledge that DevOps and cloud is a very vast and very specialized skill. It's not like Java and .NET where things will be tested in the prod, non-prod, and a lot of QA testing and those long-running activities. You are actually working with the live applications in your cloud environment. You are working on the applications which are used by your customers. So it's a very specialized skill. That's why you won't see a lot of freshers jobs available. You need to build that skill that you can manage the environment. I see a lot of 0 to 0 courses available, and they are not sufficient. They will help you with a very basic Nginx image, which you will feel confident that you have learned Kubernetes and you are very comfortable with it, but you would have not covered all the best practices. You would have not covered all the different scenarios that are possible in the Kubernetes environment. So doing this project, we are hoping that that will improve. We will try to build some differentiating skills. We will not just follow basic projects. We will try to build some, like, for example, instead of doing a basic deployment, we'll look at what other ways are possible, which are the better ways possible. Monitoring of any environment, which are the not just open source tool, which are the commercial tools available. So we'll try to build differentiating skills. So you can talk about those tools and technologies in your interview, or you can add those skills, differentiating skills in your resume, so that you, if a company is targeting those skills to such employees, they can find your resume as well. And industry always values the hands-on experience. This project, the aim is that instead of me doing everything for you, showing you a demo which is pre-prepared for you, most of the 90% of the things in the demos are pre-packaged. We just come and do final 1 or 2 commands, and it looks that you have done it, but there is a lot that goes into making that environment ready. So you do that hands-on experience. We help you in building that. That is the idea, because industry wants that sort of thing. Interview focus is on best practices, whereas the YouTube videos or the courses that we do focus on shortcuts. They will say launch something in public subnet and just get it done. We will follow some industry best practices. If you talk about those practices, you are guaranteed to be successful, depending upon the other factors. We want you to build your own GitHub code repository, which is a sort of must in the current CV or the resume that you are building. Your personal GitHub repository is as good as your LinkedIn profile, and it has to be there. We want that to be built with quality project. A lot of people, which relevant this third column, a lot of people are working in projects which are non-cloud, non-Kubernetes, but they want to highlight in their resume. So this project gives them that opportunity. And then last one is don't stay freshers. Like, as I mentioned, there is no room for freshers. It's very difficult. I won't discourage everyone, but it's very difficult. So don't stay fresher. Remove that tag, build these projects, show it as an experience. And we will talk about it, how you can do that, and a lot of other ways. So don't stay fresher. You have the keys to the kingdom in the customer environment. You are likely to not get very good employer, good project. You may not get to work in the production environment unless you show this kind of project. Who this project is suitable for? It's suitable for freshers and entry-level people. Need to have basic understanding of Docker, DevOps, etc. Not very detailed understanding. You can learn slowly. There is 5-6 weeks that we will spend in this project. You can learn during that phase as well. But if you don't have that experience, you will have to put extra effort as well. I'm expecting if you are fresher or very entry level, you would have extra hours in hand as well. So you will need to spend that. Experienced IT professionals who are switching to DevOps and cloud space, very relevant to them. They will have less hours available for every day, I'm expecting 2 to 3 hours per day is going to be sufficient to work on this project. And basic knowledge of DevOps, Docker is still required. And people who are already working in DevOps and cloud space, but not so much hands-on Kubernetes is still relevant for them. Few people joined who said they don't want to implement the project. They want to, like he's a project manager and want to understand how things work in the production and that kind of thing. So very relevant to them also. It will have made the content in such a way that we also cover a bit of theory or the learning part as well, like not just do the project alone. So we will focus on some content as well. I won't still say it's a course, won't say it's a complete Kubernetes package. So we'll try to give you some thoughts so you can build on top of that. So some theory will also get covered as we go. So even if somebody doesn't implement, they will still get some outcome, but the best output you would expect when you actually do it yourself. So when do we call this a successful project? What does success look like? So these are the three things that that I have identified. You build this project yourself with hands-on effort, your own effort. That would be a success factor. Learn in-depth knowledge of the subject and speak fluently about the subject. So the subject here is Kubernetes. You finish this project, I would expect that you would be talking, you would be explaining people that how it works. You would be probably creating blogs, you would be creating a lot of content yourself. You will be participating in meetings or in your office, or those sort of things is something that I would expect, at the end of the project improves. You showcase this project on your LinkedIn, in your resume, and back it with your own GitHub repository. If you do that, yes, this project is successful. The final third point is most important, which a lot of people are expecting, and it's to build a story. This project divided in 3 phases. We will, once this is completed, I am expecting that you can show it as a work experience for yourself. You can show it as an internship experience for yourself. That very close to an actual experience. Obviously, there won't be salary slips and those kind of things associated with this. But if you are for example, working in a company where you are not involved in DevOps and cloud, but want to use your last 6 months as an experience, you can build that story. So in the last session of the project, we will discuss what that story could be, how to showcase that kind of story that. Just adjusting. So that would be the successful thing. You build your project, showcase, build that story, that it's your project, you have built it for a customer XYZ. All right, how do we collaborate for the next 5 weeks? So I have right now planned these 5 weeks, but looking at the progress and how we made further progress over the next few days, we can be very flexible. That's why I'm requesting everyone to join this WhatsApp group. So there is a QR code, there is a link, and obviously once you join this, for the further communications will be through this channel. You don't have to do it now. You will get, but again, if you have not joined WhatsApp, then it's important for you to join. If you are in WhatsApp group, then you will get this document and everything in that group anyway. I have this WhatsApp group link was sent through TalkMate email as well. And I have sent a reminder also. So I see less number of participants in the WhatsApp group than they are in here in the video. So that definitely there is a gap, and then everybody else has to just join this. We will have sessions on 5th, 12th, 19th, 27th August and 2nd of September. And if required, if you need more help, you need more time, absolutely fine, we can extend it. All depends how we made progress. For success for us is basically your success is most important for this to be a real success. We don't want to finish it without completing. All right, let's get into the real project then. So I will bring these slides, and we'll talk about most of the slides then, and the images that I have taken are from public spaces. I have not built everything by myself, but I have tried to take the relevant screens so that you can correlate to it. And we will, if needed, we can get on to a whiteboard sessions in the next subsequent discussions and talk more about it. Before that, let me quickly take some questions. It's not redirecting to WhatsApp group. It should. You must be logged in. Thank you so much, sir. Yeah, thank you. Please tell about configuration Git repos. I have been doing Fox and doing small projects, but I am unable to get how to write properly. We will talk about it some bit. All right, no more questions. Does this include AWS also? This includes AWS also. Yes. We'll get into that. I am working on Azure. It includes Azure as well. So we'll get into that. All right, we'll move on to the project. So what is Kubernetes and why? So just to keep it short, don't want to get into too much complexity. We all understand the importance of Kubernetes. We need to understand that the containers are very short-lived, very fragile, and they are very temporary in nature. So they are not expected to be like your pets. They are treated as kettles in the industry. So they are very temporary in nature. So a Docker container would usually get very specified amount of CPU and memory. So say one CPU, 1 unit of CPU and 1 unit of memory. And you would see that because of memory leaks or because of traffic variabilities, you will see that the containers go very unstable at times, and they tend to crash very frequently in the environment. A lot of environments where they don't use Kubernetes, the only solution is to then restart the environment and hope that you have built the right automation and it will come. And then during that period, when you restart your servers, there is going to be downtime and those kind of scenarios. So basically, containers, when companies are trying to adopt containers and microservices-based architecture, they need some sort of solution that can do the health check of these containers, that can do the scheduling, that can manage the scalability requirements, and also the other requirements that you being able to move from one environment to another environment very quickly. So a lot of other benefits it brings, but the main reason is that you need a layer which can manage these containers, can do the health check, can do the scheduling and scalability aspect. So by definition, it's an open source container orchestration platform, and it's designed to automate the deployment, scaling, and management of containerized applications. So while we are learning Kubernetes, there is a bit of pro tip that OpenShift also does very similar sort of functionality. It's also built on Kubernetes platform. So once you are through with this project, try to spend additional 10 hours, 5 hours on OpenShift. That's how I got into Kubernetes environment. I started with OpenShift when I did my first hackathon. It was very smooth to build applications on that, and I found it much more easier than Kubernetes as well. So just spend another few hours on OpenShift, and I'm sure that you can add this extra skill as well to your resume. A lot of banks and financial organizations try to have their on-premise container management on OpenShift, which they later on plan to move to Kubernetes. So add this as well. So this basically helps the management of those containers that are in the production environment. So anybody using Docker would incline that they should go to Kubernetes as well. So a lot of theory here. I will try to give you some more background as to what other benefits of Kubernetes are. It will look, starting on a very textual slide, but some of the benefits that it brings so that it helps in your interviews and you can talk about it. So first benefit, container orchestration. It is managing the deployment and scaling of the container applications. Scalability. Kubernetes enables horizontal scaling of applications by adding or removing replicas based on demand. So there we will see in the project, you can specify different situations in your deployments on Kubernetes that if my CPU percentage goes this level, add additional nodes, add additional pods, add additional. So I'm going into terminology, but that is the sort of benefit it brings. It manages that automatically. High availability. Kubernetes ensures HA by automatically distributing containers across multiple nodes in the cluster. If a node fails, the system reschedules the affected containers to healthy nodes. So the Kubernetes has the knowledge and the information when it's scheduling the nodes, like where those containers have to be scheduled. We don't have to tell Kubernetes a lot of things that do this sort of algorithm, and they understand how many nodes are there, where those containers should be distributed. And if something goes wrong, it has the knowledge that it can identify the failures and can create the instances automatically. So again, we will see all these things. Portability. So this is that true behavior where you build it at one place and you can easily migrate it to any other Kubernetes platform, provided their version is matching. So something like you can build one project on Azure Kubernetes or the Kubernetes from AWS or Google Cloud or for that matter, on-premise as well. And you can very easily migrate it to other environments. So that's why in the project, I'm not specifying that you use a specific platform. You take any of them. The applications we will be able to deploy a lot of dashboards and monitoring and all other things. They all are very seamlessly meaningful for all platforms, because that is the benefit it has. You build it on one platform and you can port it to any other platform. Self-healing. Again, we discussed it monitors the health of the containers and nodes. If the container or node becomes unhealthy, it can automatically start or reschedule that. Service discovery and load balancing. So people who joined the last month's batch, we had to do a lot of load balancer related changes in our system because we were hosting our containers on an EC2 instance. But you will see that in the Kubernetes environment, we don't have to do a lot of those aspects. We will simply have a deployment file which say, expose this service, and then behind the scene, the load balancer and all other services will automatically get created. If it is AWS, it will be within the AWS. If it is Azure, or it will follow the same load balancer specifications, and things will be very automatically managed. And within the Kubernetes also, there are internal services which are load balanced automatically. So we don't have to do a lot of explicit effort to load balance these different containers. Declarative configuration. So it is very important point that it is a desired state solution. You want a state of the solution, that you want the application to have these many nodes, pods available at least. And based on the scenario, the CPU specifications, the memory specifications, it can change. So you just declare those specifications and it will ensure for you the same infrastructure is available all the time. So you don't have to, do a lot of monitoring for this. Obviously, this being in production, you will have monitoring systems in place because you want to get information in advance if some CPU is going to spike, or for example, any event is your organization is doing any event where they are expecting massive load. So their monitoring will help, but this has internal knowledge, and that it can, based on the defined configurations, it can try to maintain the infrastructure as per the declarations that you have done. And automated rollbacks, rollouts and rollbacks. So you can build your application. We will see in the project specifications that it can automatically roll out your new changes, and it's very easy to roll back things. You working with Jenkins or any other platform, you would have seen a lot of companies, they don't implement rollbacks through DevOps or such processes because it becomes very massive, because they have reached to another state of their application, and it's very difficult to roll back. But with containers and the image versions, you can very quickly roll back. You just have to update in the Git repository. Obviously, there have to be some constructs, some things are have to be followed. For that, you update in your Git repository, and it will roll out new changes. If things don't work out, you can roll back to the older version very, very quickly. And this kind of feature helps in case of any major event as well. If, for example, your Kubernetes cluster or in any event where your application is hosted in a specific AWS or Azure region, and that entire region goes down, creating a new Kubernetes cluster and rolling out applications because it's following a declarative configuration in your Git is very much helpful in a disaster recovery kind of scenario also, where you can spin up a fresh environment very quickly because it's connected with your Git repository. So we'll talk about all these benefits. So the entire solution that we have will try to make use of these features. You all go through this in your free time, try to understand these benefits in more detail. And this will make much more sense when we go more details or understand more, slight more information about the overall platform. Okay, so before we jump on to the next slide, this is the new slide that I have added. This is day X terminology. So this is not Kubernetes specific. This is an industry way of talking. Day 0, day 1, and day 2. So I wanted to bring that for everybody's knowledge, people who are not working in the industry. So day 0 refers to the activities that usually are performed before we start a new project, or before we get into the production release or get into the actual implementation of things. So day 0 is something like you would be doing a lot of analysis. Should we go for Kubernetes, or should we go for Docker Swarm or any other competitive product? So those sort of analysis you would do, like you will analyze how many applications are going to be hosted, what are the security requirements for those, what sort of plugins will be needed for your environment. So those sort of activities are more suitable for day 0, security related stuff. So this is again industry term referred in other projects as well, not Kubernetes specific. Day 1 is represented as the actual deployment of your application, which is usually you say go live, where your customers will see the product. That is the day 1, where you are launching, making it operational. So a lot of tasks, like you are setting up deploying your application, making sure your database is saving the information properly, any production testing and validation, setting up, monitoring, and alerting. So those sort of things are day one. Day two is the term that refers to ongoing activities in the project, like the operational side of it, the maintenance, the patching, or what we used to call like production support kind of thing. So those are the activities which are called day two activities. So you will be scaling your Kubernetes cluster. You will be upgrading the version of the Kubernetes. Kubernetes comes with a specific version. So you will be upgrading the Kubernetes platform. You will be patching your nodes, taking backup, ensuring your disaster recovery process works, troubleshooting, debugging, and some sort of optimization. Those are the day two activities. So the idea I wanted to bring this was, in the interviews I have seen a lot of time, people will say, how do you secure something? So in those kind of questions, you can say, yes, security is a day zero activity. How do you monitor your production environment? So talk about that. Yes, it's a day two activity. I was managing the Kubernetes cluster or the cloud environment, and I have done this sort of day two activity. So try to mention that. It will show you as a slightly mature person who understands the terms and understands or has done this kind of cloud infrastructure projects. And we will cover in the project all these three situations. The project that we will be building will try to cover all these day zero, day one, day two sort of activities. So what the project is the standard that Kubernetes offers. It's the deployment of a microservices application to Kubernetes cluster following the GitOps approach. And we will ensure that we are monitoring and ensuring that we have a good observability solution attached to our cluster. This is the overall project that we will build. This is any project we do on Kubernetes. It's going to be, because it's managing microservices, managing containers. This is the only project going to be in the cloud, in the Kubernetes environment, and we will cover all aspects of it: day zero, day one, day two. So in the day zero, what we will do is we'll set up a Kubernetes cluster and the worker nodes. We'll get into all these terminology in detail. So it will you will probably have to view the recording one more time. If you are familiar with some of the terms, you can skip, but because it's very difficult to order these slides, unless I talk about the overall project scope and don't talk about what worker node is, then it becomes very difficult. Otherwise, I have to do a lot of theory sessions first, a lot of Kubernetes overview and that kind of thing. And then I can jump into project, but that would be a very massive thing, because it's a very detailed area. It's very difficult to cover in a very short period of time. We will try to build something meaningful for showcasing in your experience, but at the same time, there will be additional things that you may have to learn. But you will get a good idea. You will get a roadmap kind of thing. You will get that, okay, if 10 things are done in this project in this way, there are additional few deployments that are possible. I can easily do that. So we'll try to cover those gaps as well. So day zero, we will set up the Kubernetes cluster and the worker nodes, understand the key terms in the Kubernetes environment, set up some additional tools with this cluster, set up the default dashboard that comes with this tool, and we'll try to integrate with third-party commercial tools for the cluster visibility. These are the day zero activities. We'll not limit to what comes by default or that kind of thing. We'll go to additional tools, and we will understand the terms, key terms, so that in the future when we are talking, you are ready with you understand those terms. It shouldn't be that you go back and try to learn those terms. So I will bring those terms. I will talk about it in the subsequent slides today. But there's a bit of homework and there's a bit of work for you that you will have to research and find out few additional terminology that we may not have covered. Day one, we will deploy a complex application that has database in microservices environment. So that's the gap I have found. People don't cover in their basic projects. They don't deploy application that has databases. or if the database is there, that is managed by AWS or Azure or some other platform, and then you just give that MySQL or that endpoint to your containers. That's not the real scenario, right? Your database has to be inside the container. Then you get the real benefits. Then you get the actual scalability of any of the part of the microservices. If you are relying on a database offered by AWS, then that is the bottleneck in your environment. If that Docker, that RDS, or that whatever that SQL endpoint that you are using, if that is not able to scale, no matter how much your user interface, your services scale, you have a sort of point of failure there. So in this solution, everything can scale individually. We'll look at 2 or 3 different topology as well, not just a specific setup. And we'll understand why these different setups are being done. So we'll go more detail. We'll understand why we need GitOps, why the DevOps, DevSecOps is not sufficient for this kind of environment. Because that's very important. If somebody asks you a GitOps question, don't just answer very basic GitOps thing. Tell him that why this is required, why this was not sufficient, the standard way of DevOps, why this is very suitable for Kubernetes and microservices environment. You just speak on this for 5 minutes. Trust me, you will have added advantage in your interviews, not just basic answer of what GitOps is. And we'll following the GitOps approach, we will be installing application in this in our cluster using ArgoCD. We will look at other deployment options, blue-green, canary deployment, rolling updates, and recreate, where we destroy everything and recreate from fresh. So we'll look at different deployment strategies with our solution. Day 2 is when we have launched the product. It's used by our customers. We will make changes to scalability requirements. We will increase the number of pods, nodes, cluster containers that we have from 3 to 5, 5 to 3, that sort of thing. We will be monitoring this using the open source tools, as well as we will look at the commercial tools that offer free trial, because that adds an extra advantage. One thing I missed out adding, we will not just look at the basic observability. We will look at what those metrics are that should be tracked, what those, we'll go a little more deep into this area as well. And I will add that point that we will look at those detailed monitoring points, whether it's logs monitoring, what kind of metrics we can get from logs, and what sort of metrics should be monitored. So that is the project basically at very high level. We will try to cover all these aspects. Okay. Any questions so far? So I get a bit of breather as well. Are we going to focus on setting things up using infrastructure as code, Terraform? Yes. OpenShift is free for 60 days trial. Awesome. Saurabh, thank you. So yeah, OpenShift, you can add that as an extra skill later on after you have done this project. OpenShift is not open source. Okay, you responded to this one. I think I should. Architecture and also we will get into all that. We will get into these questions. Do we get recordings? Yes. Can you show WhatsApp QR once? Are this day 0 done in sprints or single day? So I will be explaining this in, so these are the questions that I'm reading from the chat. Some of them are direct messages, so you may not see that. So are all this day 0, day 1 are going to be done in sprints? In actual project, yes, you will have dedicated effort and time for day 0 activities, And there will be, that's why I'm saying it's not a 1 month project. If done in an industry, if done in a company, you will have a lot of formalities, you will have a lot of reviews happening, you will compare a lot of products. We will not do those sort of activities. That's why we will be able to do it in, say, 5-6 weeks. And that's why it can be very helpful to justify 6 months of experience covering all these 3 things. We will be getting the document sheets. Yes, you will be getting this presentation. Don't worry, I will publish this on. Where does cloud comes into this picture in this project? We will look into the cloud. The Kubernetes, the environment, we can host it on on-premise environment. We can host it on any of the cloud provider. All the cloud providers have taken the open source project, and they usually don't modify anything on top of it. If they modify the out of the box Kubernetes framework and add additional things, then it's very cloud specific implementation, and it removes the portability feature of the platform. So to ensure portability across different cloud providers, that's where the cloud comes into picture, because the worker nodes that where the actual work is going to happen are nothing but basically your EC2 instances, your Azure VMs. So that's how it's all connected with cloud. Can you give QR code once? So this is the QR code on the screen. Will not database as service be more scalable than microservices-based deployment? It can have its limitations. The database as service, you cannot provision the scalability requirements upfront. So it may not be able to scale that much. But if your entire application is microservices, including your database, then your scalability is in your hand. Which tools am I supposed to install and set up in my local machine? Exactly. We'll discuss all this. We will discuss what tools you need. Are we going to use managed Kubernetes or setting from scratch? We will discuss this question. Can we implement the project in Azure DevOps? Yes, you can. How can we have database in container, as container is temporary, ephemeral? Yes, we will discuss that. That is the whole thing, idea, that how do we have database in the container? AWS free tier account is sufficient for this project, or we have to spend some money? You might have to spend some money. You might have to. I am not so sure how much the free tier will help. There may be limitations. You may not be able to do everything in the free tier, but the cost is going to be very minimal. All right, we'll skip these questions now, and we will jump on to the part, because I see a lot of questions eventually get answered. All right, so let's talk about some of the terms. I have already talked about few of these, but let's now start to understand these terms in little more detail. So what are the key terms and the architecture of Kubernetes? You can find a lot of documentation about Kubernetes own website and a lot of other videos. We will talk about the key things that people need to understand. And the idea that the roadmap or the input that I want to give eventually is that what we should not do while doing this project, or in general while we are learning Kubernetes. Let's talk about the first term called control plane. So a Kubernetes architecture is sort of not really a client server architecture, but it's like there is a master and then there are worker nodes. So something like Jenkins, where Jenkins is having multiple build agents available to them, and Jenkins drive that, okay, this is a build agent for your .NET applications. It has a label associated with it, and then all the .NET builds will go to that machine. Same Jenkins master will have some labels associated with the server where it has specific PHP or specific applications to be built, Node.js, and so those building of those applications will be directed to those nodes, those worker machines, build machines, whatever you call them. So all Azure DevOps, all those GitLab, CI, that process works on this master and worker node architecture. Exactly same architecture is applicable in this, where you have a control plane, which is the you can say the brain of the cluster, and then there is data plane or the worker nodes, where you have different, your applications are hosted, which requires scalability, which requires adding of additional nodes. So on the left hand side you have control plane, and on the right hand side you have different nodes, node 1, node 2, node 3, and then at the top you have the cloud provider API. So if you are hosting your Kubernetes cluster in a cloud, then then there is a component in the control plane which has the capability to go and provision cloud specific resources. So I talked about load balancer, and we'll talk about storage in the subsequent slides. So to set up a production grade cluster, your control plane should have permissions so that it can create cloud resources as well, because you will not do that those activities. Your focus is on building your application, deploying your application, which is on the nodes. So a lot of videos, a lot of things talk about understanding or setting up of your own cluster, your native cluster, that typically the word get used. You set up your own cluster. Usually that is not the industry practice. 99% of the companies use a managed Kubernetes cluster. When it comes to managed cluster, what we mean is that managing of the control plane is the responsibility of the cloud provider. Just like managing of the EC2 instances, there is part responsibilities with the cloud provider, that giving you the compute power. Installing applications, making it secure is your responsibility. Similarly, manage Kubernetes cluster, you get all these components on the left hand side are provided by the cloud provider itself. So we don't have to get into all those details of that. But for our understanding, we should understand what components go into a Kubernetes cluster, because those things get discussed in the interviews and in the day-to-day life. So the scalability and the availability of the control plane, again, responsibility of the cloud provider. The cloud provider, for example, in AWS case, ensures that it is available across different availability zones. So you don't have to worry about that. That actually, helps us to not focus so much on managing the control plane side of it. Otherwise, and just 1% or very specific customers, which are like Google or Netflix, or they may be setting up their own clusters as well, but they are very high mature customers, and usually they are not our target employers. Those are very specific use case, and in that case they manage their own control plane as well, but it's not so relevant for 99% of the people, the companies that are using Kubernetes. So what is one component in that is the Kube API server, which is the you can say the entry point to your Kubernetes environment. All your interactions, all the tools that you install, all communications that you do with your cluster is through the API server. So this is important for us to understand that all our communications are happening with the API servers. etcd is a sort of key pair database, which is stored in the control plane, and it maintains that on node 1, how many different containers are there, what is the health of those containers, a lot of information about the cluster itself. That gets stored in the etcd database, that is in the control plane. we hardly touch or we hardly know how it's managed, how it's stored. That's all managed by the API server itself. There is a component in the control plane, which is kube scheduler, basically scheduler. Which is based on the information it receives from the API server. It connects to the nodes and it basically has the scheduling understanding. It reads the information from the database that specific application, there are two containers and they need to be on two different nodes. So then I need to schedule it accordingly. If one goes unhealthy, then it has the understanding that if it is unhealthy as per the desired requirements, there should be another node, another pod, and then it will go and start that. So that sort of component. Why I'm taking it slightly lightly is we don't have to manage this. This is the easy part of this one. There is controller manager and cloud controller manager in this. Cloud controller manager is sort of optional if you are hosting it in any cloud provider, and the specification of that will be based on which cloud provider you are hosting it on. And then the two important things that are kubelet and kube proxy. Again, not so relevant for us to understand. This is the architecture of Kubernetes. This is the components that Kubernetes control plane manages on the node. This is the slightly easier part. Where it gets complex is the subsequent slides. Kubelet is one component which has to be on every node machine that it's managing. Again, when you are adding a node through the cloud provider interface, the kubelet gets automatically installed on that node. The kube proxy, the management of, I talked about inter-service communication in the previous slide, that services talk to each other in the Kubernetes environment. It manages the load balancer part of it, managed by the kube proxy. So these are the terms that usually are provided by the cloud provider that it's going to offer us. We don't have to go very detailed into these areas, but we need to understand because they come in the they may be used in the communication, but they will not be asked. We will not be asked to set up these things by our hand. We will be requesting through Terraform or through AWS or Azure console, and these things will be made available to us. Where things get complicated, let's a bit of theory. It's pretty much, I have covered all these things. The control plane is the brain of the cluster, coordinating between different other components of control plane. Some of the components are API server, HCD, scheduler, control manager, and cloud control manager if you are running in a cloud provider. So you can read about it. We have already talked about it in the previous slide, but I just want to bring it here so that you don't have to go online or search from any other place. Let's talk about the things where it gets complex, the things where we are more concerned. And just a slight tip here, not you can follow your own learning path or something, but this is the terminology and stuff that usually a DevOps or a cloud engineer or an operations engineer or cloud native architect or whoever is managing the day one part of your cluster is concerned, how to build, how to package, how to deploy your applications. Not so much about the control plane side of it. So there are two certifications in the industry, which are CKA and CKAD. So if you are planning for any Kubernetes exam, I would highly recommend going for CKAD first, where you are focusing on the deployment side of the application, building side of the application. A lot of architectural side of the things, obviously you need to know those things as well, but if you want, these are very expensive certifications from Cloud Native Foundation. And if you have to really do one which covers most of it, try to do CKAD, which focuses on this part of the setup where you are building and deploying applications. That's on the side note. Let's talk about this. On the key terms that are used in this are namespaces, pods, deployments. So what are these? So namespaces are something like in the overall cluster that you are managing or your company is trying to deploy. It can be used by multiple applications. There could be multiple environments in the same cluster sometimes. So you want to differentiate that this is the dev environment for team A, which is a front-end application. This is a different application which manages a different product, and it's a different environment. So namespace is just a sort of collection of those further deployment that you are going to do. So it's just a sort of umbrella term used for differentiating different applications or different environments. That kind of construct, nothing to do with any detailed understanding of Kubernetes. It just holds your different other components. Pods. A pod is, again, very common question. Interviewer would want to check with you what your understanding is probably the smallest item that can be deployed in a Kubernetes environment. Now, a pod can have more than one container images inside it, but typically I have seen that as a best practice, it's advised to have one pod and one container sort of thing. So a one-to-one relationship, so that you can scale your entire service because it's in the one container. If your UI layer is seeing a spike, then just scale the UI layer, not the database layer. Database is a separate container, so you scale the separate database separately. Deployment, how you deploy your pods and replica set and all other components. Deployment is a term used in Kubernetes to specify that you are going to deploy a pod in your environment. Replica set is, you can say, when you are deploying pods, you don't just deploy one single pod. You specify that you need multiple replicas of that pod and then load balanced. So once you deploy a replica set, multiple pods can be created and they are automatically load balanced for you through a replica set. Secrets, very common question in the interviews. What are secrets? What sort of out of the box secret management Kubernetes offer? So you can create a lot of base 64 encoded secrets in Kubernetes. So then you can use to set password for your MySQL database or RDS or any such stuff, and you can use it in your applications, those secrets. Kubeconfig is a config file, very similar to the credential files that we use for AWS connections. So once you do AWS configure on your CLI, you get a configuration file which has the credentials available, basically a config file and credentials for your AWS account, where you store access key and information. Similar to SSH public and private key setup. So kubeconfig is that file. If that file with a specific role is available to you, you can perform those activities onto your cluster using that file. So that it's basically a secret file. Stateful set, persistent volume claim, Kubernetes taints, config map service. I would request, because this is the main subject of this, you also spend a little bit of time once you don't just finish. I will try to simplify it for you. I will try to give you a narrowed version that focus on these things, but at least focus on those areas and ignore the rest of the things. Stateful set, for example, you are going to build a lot of stateful applications. So a default deployment of a pod that we do, where we cannot, it is suitable for, say, applications which are not going to save anything on the disk, those kind of thing. But if you need, for example, a database or a microservice which has some storage, you would go for a stateful set. Persistent volume claim, we will talk about it in the subsequent slide in more detail. This is to make sure that your containers that need to store data locally, for example, a database container or an application which stores some logs or something, some processing information. Some of the microservices are built like that. They are not stateless. Stateless means that you kill that microservice, you provision another one, nothing will be impacted. But there are microservices which store some data locally as well on the disk. And in those scenarios, you need some persistence volume and volume claim. So we'll go. I have added specific slide for these. Kubernetes taints are very similar to the label construct that I talked about in the Jenkins. So every node, every cluster node, you can specify specific taints that this machine or this node, this EC2 instance is very suitable for hosting this kind of application. It has a specific .NET framework or something like that. So those applications will go there. This node is specifically for database hosting. So you tell Kubernetes that my database containers should go on a specific node. So then you can use this feature. Config map and secrets are related. Services, we will again go deep into this. As I mentioned, we can expose the containers, the replica sets that we have created in the environment as services, and services are 2 or 3 different types. We have internal services, we have external services. Internal services, which will, the type is usually specified as cluster IP, and then there are external services which are load balancer type, which are exposed outside. You can expose it to the internet or you can expose it to the other endpoints in your environment. So we will try to build on these lines in the subsequent slide. And all these things, some of them are very important for day 0 activities, and some of them are day 1, day 2 activities. So we will get into that. So data plane or the worker node, there are 3 components on this. Kubelet, which is an agent running on each node in the cluster. It is responsible for communicating with the control plane. If there are some scheduling instructions have to come, obviously it will talk to the API server because that is the only entry point. That's where we talk to someone. But if new scheduling has to happen, it has to inform pods that are not healthy or that kind of thing. Then kubelet is that thing on the container on the node. Container runtime is your Docker or any such runtime which will be pulling those images, because you will specify that pull a specific image of Nginx or MySQL, and the container runtime is going to do that. kubeproxy is also running on each node, responsible for routing traffic between different pods and also the load balancing side of it. They will sit in a separate sort of namespace. We will hardly have to interact with them, but over a period of time, we will build more understanding of kubelets, kubeproxy, if we have to have a very complex use case, but otherwise we don't have to interact with them on day-to-day basis. Control plane is the master of the master instance in this, that is driving all the container placement and all based on how we tell it to, and rest of the things it manages behind the scene. So some sort of analogy that I was thinking, that we do a lot of things where we are not so much concerned about the complexity of the solution. I was thinking about a scenario where the money printing, for example, we have been consuming money in our countries, in our different regions, but do we really understand who prints that money, when do they distribute, how they distribute? We don't care of all those things, right? It's that sort of concept where some of the things we don't have to really understand deep down. The control plane, for example, the lot of components of the control plane, that's managed by the by someone else, by the cloud provider, unless I'm managing it myself. I'm creating it, which is very, very rare. So it's very similar to that example of financial stuff. There is usually an organization or a team that manages in every country when something has to be printed, when there is a deficiency of some specific money denomination, and then the distribution, printing, and those sort of things. So it's very similar to that. There is a control plane that is the brain that's managing all this based on what we define, based on the information that it finds in the running environment. Something is not healthy, it takes decision based on that, gets that information, and starts working on that. So very similar to that construct, that we don't really have to understand everything sometimes. What we understand is the data plane, the application that's running, and the containers that are running. So specifically, I thought of bringing these three terms here: persistent volume claim, and storage class, because these are related to your day zero activities, your setup of your cluster. Because a lot of containers that we will build or used in the industry, you are not just setting up a cluster, you are also setting up a storage with that cluster. So for database to work properly in the microservices, storage has to be there. You are basically, your microservices are basically the compute power of it. So database is different than a front-end application. So for example, if I have a front-end application which is in Node.js, then it gets a request, it processes the request, they create the required HTML or whatever is the requirement of that, talks to a database, fetches it, logs you into the server, and sends the request to the requesting client. It has only the compute power, basically. But when it comes to database, it has to store something. So database is complex because it has compute as well as it has to write something on the disk. So in the microservices world, you are basically containerizing the compute side of it. The storage and those things you still have to manage yourself. So these three terms have to be configured in advance. So on the diagram, you will see that there is a pod in the Kubernetes cluster, rather two pods, and they have been deployed, and they need persistent volume. And on the right hand side, you will see different storage classes. You have AWS EBS, Azure Disk, Azure File, GCE persistent disk. So based on where your cluster is hosted, these are the options you will have. You can create your EBS volume or Azure Disk, etc. in your environment, and make sure that your cluster is made available to it. How it requests is that a storage class can be, there is another type of manifest, another type of file that we will write, which will say that I have defined a storage class in the form of EBS volume, and then the pod can request a claim. Means that a pod requires 5 GB of storage. It needs 5 GB of storage for writing to some location, or the container that for example, that database writing, it will request. A claim is that they are requesting 5 GB of information, 5 GB of storage for that specific pod to write. And the persistent volume will actually go and create that 5 GB on that specific storage that has been created in advance. So that's how it works. Persistent volume will actually create that storage and make it available to you. A pod will request it through a volume claim. That's how all these things are sort of related. And in our project, it's going to be useful. And why I brought it specifically early is because it's a day zero activity. You need to build it along with your cluster as well. Okay. So first task of the project, first day zero activity that we will focus on is setting up of a cluster. So what are options we have? A preferred option is, as I mentioned, and is a best practice also, is to choose a cloud provider that you are working on, choose EKS, AKS, GKE that you are comfortable with. Obviously, it will come with some money. So my suggestion, or I would suggest that you build some sort of automation if you are using this option. We have 5 days to do this, or maybe longer as well. The advantage with the automation is, or with the Terraform, would be that if, for example, you work 2 hours on your cluster and you don't want to leave it running, you can destroy those resources. You can stop those resources, and so that you stop consuming money on that account. So try to build it through Terraform. Otherwise, if you do it manually, you will have to delete all these. You have to go to EKS cluster. You have to go to storage side. You have to go to EC2. You have to look for load balancers. Any of those things that you have created, you will have to delete them manually. So try to use Terraform if possible, but it's again not mandatory. If you have not done Terraform or not build it, other options, we will talk about the other shortcuts and other options as well. The objective is that by the end of this week, next 5-6 days, you are comfortable with most of the terms that are on the node side, the worker node, the terms that we discussed on this screen, the namespace part. You read the theory, you be comfortable with this, and you make sure which container platform, based on your situation, based on the funds you have, based on your employer direction, which platform you want to build. There are free options as well. There is a very good option from Civo. So it's not directly free. They offer you 1 month of Kubernetes platform, but they need your credit card, but they don't charge you anything for the first month. So you make sure you cancel your subscription after 1 month. So this is not absolutely free. You need to provide your credit card to them. You can sign up on their website. Minikube, you all know, is you can host it on your own laptop or your desktop itself. So I will just go here and is this page visible on the screen?
Yes, it's visible.
Thank you. DigitalOcean is also a good option. Yes, it doesn't matter actually. So you go for it. Any platform where you can set up your cluster, that's all acceptable. Minikube, you can set it up on your laptop itself. If need to have some good configuration, because the things that we will set up, the containers and multiple containers on your environment, so they need the information, they need those resources. So Minikube, you can follow these instructions, which is your operating system. You can do it on an EC2 instance if you want to in the cloud. Based on the architecture, any release, package manager, and basically what I did was I did this one. So I ran this command, this one, and start. These 3 commands will give you a working Kubernetes cluster in like very few minutes. Obviously, it will ask you to ensure that Docker is running, your Docker desktop is installed on your machine. Depends where you are trying to do. I have usually done it on, I use Ubuntu. I use Ubuntu on the Windows, which gives me access to these sort of terminal. So that I don't have to leave my comfort of my Windows environment that I'm used to, but I'm also having a full-fledged Ubuntu Linux environment as well with me. All right, so that's up to you, how you want to set up. Make sure that you are able to delete it, or able to, if you are going to create it in cloud, you will manage, you can destroy those resources. So again, a very sort of high level, we'll talk about all this kubectl, what it is, what application clients is, but at very high level, you will end up creating a control plane. You will create a VPC, and you will create worker nodes. So start with a small worker node, and then we can later on we can add more depending upon our use case. So end of week 1, you try to be at this level. We have still more slides for week 1 itself, but this is the objective, that you decide where you want to install, and if within the WhatsApp group, when I open, if you want to create small individual WhatsApp group of people who are focusing on EKS, they can have their own small group if they want to, AKS specific people and GKE. That's how you guys can collaborate on that group and communicate with each other, because that has been helping in the previous month as well. Like somebody is not there to answer, you can get help from people who have been able to do it. And because there are in the previous project, it was specific instructions. Because Kubernetes is more interoperable solution, suggestion is you focus on based on your employer direction or your own interest. So that don't want to restrict it, because that is the key feature of the platform. So you do it based on your situation. For students and all, Minikube is also fine. You try to set up this through Terraform if possible. Amazon EKS, for example, this diagram is for Amazon EKS, but very relevant to Azure and Google Cloud as well. Amazon EKS runs and scales the Kubernetes control plane across multiple AWS availability zones to ensure HA. Amazon EKS automatically scales control plane instances based on the load, detects and replaces unhealthy control plane instances, and automatically patches the control plane. So all those things are managed by the AWS of the control plane only. So most of the things that, the control plane complexity is sort of gone. So we have only the right-hand side, the worker nodes complexity to manage. Combine them together, it's a beast you cannot control, because things will be out of sync very soon. Because AWS is managing 50% of it, that is where it has become production grade. A lot of companies have started using it. Otherwise, it wasn't that popular in the industry. It was mainly because Google, Netflix, Facebook, these sort of companies use it. It was talked about in the interviews, and that's why that meme, it gets talked in the interview but not used in the companies. But now that's not relevant. So kubectl is one of the very famous client for interacting with, and it is talking to the API server here, talking to the API server of the control plane, and interacts with it using the kubeconfig file that it has. So now it will start making sense, the terms. So you will have that kubeconfig available to your machine where your kubectl is installed. It could be the machine of a DevOps engineer, cloud engineer, will interact with the control plane. This one will interact with the clients. Your UI, your database is exposed in this, that will be used by your customers. Again, very high level, don't want to get into too much complexity. Otherwise, this becomes sort of any other YouTube video where they will have everything provisioned for you and you won't get to work on it. We want to build it step by step, and we want you to build it so you get a good understanding of it. All right, so we have multiple options. So want to talk about some of the key activities for cluster setup. Choose the right EKS version. So these are more relevant for your interviews and for your discussions. A bit of understanding as to what goes into setting up of Kubernetes cluster. Choose the right EKS version. Now going a little bit AWS specific but choose the right version of your Kubernetes environment. Not, for example, you are coming from your on-prem environment where you already have a cluster setup. You know that it is working or for a specific version of Kubernetes. Maybe before I jump into this, I can show you something which just so you get an idea, let me refresh if it is not logged out. So we created this cluster on, so maybe you can see the screen, my AWS account.
Yes, sir.
Yeah.
Yes.
So we can actually just take a look how we create a cluster. We have to specify the name of the cluster. We need to specify a version. Now this version is where you have to think the code that you are bringing, just like how you decide your Terraform code and your Terraform version and stuff, how your deployment files have been tested within specific environment. You need a cluster role. So because you will be creating a lot of AWS resources as well, or the control plane is going to create those resources for you. So you need to give a role in that, and there are documentation where you can specify what goes into that role. Turn on encryption for this. We don't enable it right now. And the VPC has to be created in advance. This VPC is nothing but okay. One thing I forgot again to mention, because AWS is managing this entire thing, this is hosted in the AWS VPC. So you don't even host it in your environment, in your AWS accounts, the control plane alone. This is done by AWS itself in their own account, in their own environment. So again, removes complexity on you. You don't even see this where my control plane EC2 instance is. That's covered in the pricing of the cluster itself. Whereas if you add 3 worker nodes, you will see 3 instances created in customer VPC. This is your VPC, your network that you have configured. Same for Azure and other stuff. The Azure will manage this and will manage it in their account. And the pricing will be accordingly. You will not even see where this is hosted, because everything is hosted on an EC2 instance or a compute instance. But you won't see this. So when it's asking for VPC, it's basically asking you where these your worker nodes will come into picture. So you need to tell it the VPC, the subnets. Obviously, as a best practice, the instances will go into a private subnet. They will not be into public subnet. Will not have a public IP attached to it. For practice, you can do whatever like shortcuts you take, but in any production grade instance, security groups, how your for example, this is a MongoDB container, or it's a MySQL. They operate on different ports. So you will specify what security groups those containers and those ports will need. So you will open up those security groups. So that you will specify these things. And the cluster endpoint. Do you want the cluster endpoint to be public and private, and private? Now this becomes very, very complex. What I have seen from my experience, companies start with a public or public and private kind of subnet, and when they mature, then they go fully private endpoint. I will try to bring sort of demo or something in the later sessions. Otherwise, this will become very, very complex in the first week itself, because we are building it slow. So let's go keep it public for now. The cluster endpoint is accessible from outside of your VPC. The worker node traffic will leave your VPC to connect to the endpoint. So this is what it's talking, that the load balancer that it will create will be accessible to the public, or that kind of setup. Logging, we will just keep it no logging for now. We will not change anything, and that's all is needed for setting up a cluster. If there are any specific requirements, we can provide, but as of now, there is no such bias. There is no such use case for us. That's all. And create the cluster. I will not create another cluster because one, it will take time, and the other, it will be having some cost associated. So I have this running version, and I don't have, this is how you will see a cluster being configured for you. Right now, it does not have any worker nodes associated. So basically, we have only created the control plane of it. If we have to add worker nodes, then we can add a node group. We can specify a node group name. Because the node group may have to interact with other cloud services, you will have a role associated with this. Again, there are information. I have created this in advance. There are documentation as to what is the right role for your worker node. You can also use launch templates. You can have auto-scaling groups or that kind of environment where your worker nodes will be created across AZ or the typical auto-scaling construct. Or you have predefined AMI to be used, predefined EC2 instance to be used. So you can use launch template. I won't use this. We will not add any taint or anything, and just specify which is the AMI type you want to use, Linux, Amazon Linux, or any, again, depending upon your use case. If your Kubernetes cluster is used for machine learning projects, or if it is Windows kind of projects, you will choose based on what kind of this instance you want. Whether you want on demand, whether the application that you are going to host, can it work on spot instances? Can it, if AWS needs those machines, you understand the difference between spot and on demand, right? It can terminate anytime. It will give you a notification for 1 minute that the machine is going to go away, and the machine will be terminated. But the pricing is like it's 90% cheaper. So can the application need to be designed that way? Can we do that? I won't get into these details. What is the node that you want? How many nodes you want? We will make it just one. And we will just say. So even if you have to do it through Terraform or anything, it will not be a massive lines of code. It will be a VPC, a cluster, and a node group, and an EC2. So it will be very less number of lines, and you will probably get the Terraform templates and Terraform modules available. There are a lot of them available, but you may have to update the latest AMI. You may have to update the latest the version of the Kubernetes and in the Terraform code. With my this is some sort of deployments and things that I was trying on this cluster. So all right, so you see that that I had already kubeconfig available for this, and I will give you the commands how you can get that if you really plan to do it on EKS. This is the node that it has created like 25 seconds ago. And I think it would have come healthy here also. So a minute ago. So, but there is a lot of preparation that has gone into this one. The cluster was already created for you. The kubectl, I have like created alias in my environment. So K means kubectl. So I don't have to type it many number of times. And the kubeconfig, the access to this was already available. So that was the preparation that was already there. This instance is available. So we'll not get into this. I will clean it up. What we want to discuss is select the right version, configure your VPC and subnets. As a best practice, you can enable those logging that we saw, but we will not do it for our purpose in this. In future, if we have to do detailed monitoring, we will get into that. Set up roles that we mentioned, the roles that 2 roles have to be created, one for cluster and one for the worker nodes. Secure your cluster endpoints. So these are the activities and things that you will talk to your colleagues in your companies while you are planning to set up, adopt Kubernetes cluster. That's why it's a day 0 activities. What are your backup and restore strategies? What sort of policies you have to implement? What sort of naming convention have to be there? For namespace, what naming conventions have to be followed? For pods, naming conventions. So because these things will have the names associated, we'll see when we get into actual deployment, when we try to deploy something, naming conventions are very useful to identify the resources. Day 1, we need to ensure that we are using secrets and config maps for sensitive data. We are following namespace best practices, organizing different applications into their own namespaces. Use managed node. We created a managed node before we created the worker node for in our environment. We saw that. Managed node means a lot of overhead managed by AWS itself. We use auto scaling. So we use automatic scaling of our worker nodes, which can be an auto scaling group kind of setup. So not only containers, but if the control plane has to add additional nodes to the environment, that can be done. Monitoring and logging, network policies, rollback and updates and rollbacks, and horizontal pod scaler and GitOps. So these are the things you will plan on your day 1, or you will plan for day 1 when you are going to go live with your cluster and you will be going to deploy some applications on top of it. Do a bit of theory, because I am trying to bring a lot of content which will probably disturb the flow a little bit, but I want you to take this information, get the direction, and in your next week, build that knowledge, build those terminology, build those that understanding, so that next week when we come, we will not talk about these. We'll assume that you have gone through the theory, you have gone through your own research in the next 1 week, and you have built that knowledge. Some key activities done on day 2 are your Kubernetes keeps on releasing new version, new patches, new upgrades. So you have to maintain your environment as well. So Kubernetes version upgrades, nodes have to be maintained, nodes AMI may change, that kind of thing. You will keep on maintaining your worker nodes. You will test your backup and disaster recovery. You will bring down every node. That's a regular activity companies do. They take down their applications when the customers are not using it over the weekend or something like that, and test that they are able to recreate it. So you will do that as a part of your day 2. And we will also see when we build this project, we will terminate some instance. We will play around with some scenarios where we delete all the pods. We will forcefully, in our configuration, we will say keep 3 pods, but forcefully we will delete 3 pods from the behind the scene, forcefully killing them. And we'll see, can Kubernetes bring them up or not, that kind of scenarios. You will do cost optimization, security scanning, audits, reviews in your environment. These are your typical day 2 activities. Do read them in the next week, build a bit of knowledge around it. It will be very helpful in your subsequent discussions in your companies, in your interviews. Overall, good practices to be followed. Very commonly asked, okay, what was your approach? So while you were working, because you are going to claim, say, 6 months working in Kubernetes or more, you just talk about these points. We used managed Kubernetes service from cloud provider. We used infrastructure as code like Terraform to create the cluster. We implemented the monitoring and logging. We used centralized ingress controller. We will get into this a little bit later. We set up role-based access control for our cluster. We have used GitOps deployment method, and all our secrets were properly managed and encrypted. So these are some of the best practices that are to be followed, and we need to understand. We will be implementing them in our project. So it will be much more clear when we start implementing them. We'll talk about all of them again in the subsequent slides. But another thing is, like, we can set up all these policies and so many other things, but how are we going to avoid that, those kind of misconfigurations? So once you set up your cluster, it on any environment, for example, Minikube, it takes very less time. Took me half an hour to set up the cluster on my laptop. Same with AWS and other, if you do it manually. So that takes small time. So in companies, because the things flow automatically from your Git repository to your environment, and GitOps approach, when we discuss, we will talk about it. There is a very good chance that a lot of misconfigurations can go into your environment. How to avoid that? There are many tools available, commercial tools, and that we can integrate. This is something I found very interesting. It's called Tree, and Tree or Dartree. So it's commonly called Tree, and you can integrate it with your cluster, and then you can define a lot of policies in this tool. You can define policy that a pod, a container image which is running as root user will not be allowed. So then you cannot run that. So before it gets pushed, before it gets deployed, this tool will prevent that. So we will test it. The only challenge I found was for us to practice and to do a lot of things. This will start preventing a lot of our play around that we have to do and that sort of thing. So we will, in our test environment, we will set up this tool. We will watch some of the things that it offers, and then we will decommission this. So read about this. Wherever you set up your cluster, try to integrate with this. There are 2 or 3 steps, because there are 2 or 3 steps. I will have some commands listed in the document, and on their website also. It took us like very limited amount of time to convert this, integrate this tool. Can be very helpful in your interviews. How do you avoid misconfiguration in your environment? What were the security tools that you used? What sort of commercial tools are you comfortable with? Any such question, you can bring this kind of reference. But we will delete that also afterwards, because it interrupts our practice. It interrupts our day-to-day stuff that we want to do. All right, somebody had question, what are the different tools that we will use? kubectl is one such tool which we will use to interact with the cluster. Very commonly available. You can have alias created in your Linux environment where you don't have to type it the entire word frequently. You use it, the admins and the DevOps engineers use it 90% of the time when managing their looking at their cluster resources. And Helm is sort of package manager for Kubernetes, something like Docker, GitHub, you can say, or any such Python package manager or something like that. So you will see a lot of companies publishing their product as a Helm package in a specific package repository. So tree, once you have to install this, they will ask you to refer a specific package manager file, and Helm is required for that. So you need Helm installed on your CLI, so it can then download any package and install it in your cluster. EKS CTL is a very specific for AWS users. EKS specific. EKS Cuttle is you can create clusters using this command line. I will have others command, very straightforward to set up, but the drawback is that it will follow a lot of standard practices. It will create your cluster with M5 large instances, and it will be very if you don't provide all the parameters, it assumes a lot of things, but it can very powerful that it can create cluster with one single command. Prometheus and Grafana, we will mostly for your monitoring kind of thing. Kubernetes offers a default dashboard as well, so you don't have to run your kubectl commands all the time. You can follow you can view your container environment and everything in the form of dashboard. We will also set it up as this week. So do read this material. This is the tree app, and this document talks about a lot of best practices setting up on EKS, but I don't want to get into all that. It's a very lengthy document, but do read it when you get some time. This is the default dashboard, and it's not a good practice to install Kubernetes dashboard in the production environment. So we will still do it for practice purpose to visualize our resources. You will see that on all the pods, the jobs, the replica set, stateful sets, all those, the persistent volumes, storage classes, everything gets, visualization is very straightforward in this, but very hardly used in the production. Unless a proper role-based access is configured for your environment, then you can say that. But otherwise, a lot of alternates are there, and I have tried to bring 2 or 3 such alternate which are commercial, and I think they offer a sort of free trial. So you can, once you set up your cluster, no matter where and which environment, all these tools will support. You can integrate, try to integrate these, or try to bring your own Kubernetes default cluster just to visualize things. It's very helpful when you are developing things, when you are practicing things. Instead of, once you deploy a container, looking at a command line and then looking at a dashboard is 2 different things. So it will be helpful for your day-to-day operations. Okay, here are some commands that I used. As I mentioned, I have done some sort of prep work. So the prep work was I had a cluster control plane already configured in my environment. Then I used this AWS EKS, the region name, update kubeconfig, and the name of my cluster. This is that command that will download the kubeconfig file into my environment, which will allow me to talk to this cluster. So basically, run this command on your control in your terminal once you have created the cluster, and your terminal will be ready to start firing kubectl and other commands. EKS CTL, you probably don't use this. There is a question. Someone
No,
else?
sir, that was my mistake. So
All right. Okay. Then you can install kubectl in your environment. I have listed down some commands. They are from the official documentation. You can always go and try to install kubectl on your machine. It's a small binary that gets installed. You can follow this. To install Helm, you need these three commands. Downloads the Helm from its repository and installs it in your environment. So get to this level in the first week. Once you have installed Helm, you go to online and search that how you set up your default dashboard for cluster. Then it will give you some package reference and you can install that. Okay. So this is what we want to achieve in the next 5-7 days. It looks very difficult, but it took us a lot of time, probably a day or two, basically. But if you have to build Terraform, you have to build other stuff, it will take some time. So, and you also have to read about different types of deployments that are possible in the environment. I don't expect you to deploy an application in this week. I don't expect you to deploy anything that you have custom built. Deploy something which is available online. This documentation is available. Maybe a Kubernetes dashboard and maybe a tree integration. This one, it's very straightforward. You just log into this website. It will tell you that you run these commands in your environment from the Helm package. Make sure that you have these things installed in the environment first. So reach to this level by end of week 1. That is what is basic expectation, that you decide where your cluster has to be and you reach to this level.
Sanjeev, couple of questions if you can
Yeah,
probably
sure,
guide us
sure.
through.
Yeah.
Perfect. All right. So the first one is based on experience, what tools and I'm talking about the useful tools which will definitely help to crack the interviews on a professional level. So what are the tools you will recommend that would help us to configure it, because first week is going to be with us what tools we need to decide, right?
Yeah.
So according to your experience, what tools we should be moving forward? Like if AWS is the preference, should we really manually creating the EKS, or we can use Terraform or such? If you can please advise on that.
Sure. So the first major decision is I mentioned selecting which cloud provider you want to go with. If that is the major decision that you have to make, that is entirely your decision, entirely depending upon your bias. So think about it, where you want to build your skills. You are an AWS person or Azure person, or your company is on some platform. Typically, there is a bias based on your employer and what you are learning. So follow that, I would suggest.
So yeah, AWS is what I prefer. Now with AWS also, should we really manually creating the EKS, or Terraform IAC tool we
Terraform,
should be using?
preferably
Yeah.
Terraform.
Okay.
If it is, you are comfortable with that, and for example, if you are comfortable, it won't take you that long, first of all. If you think that Terraform is not the skill you want to build in this project and you would rather want to focus on just Kubernetes, then you can do it manually as well.
Which one is more cheap? More affordable, if you can
there are
tell me.
advantages and disadvantages, right? The Terraform
Okay.
will take some time, but suggested is you do through Terraform. But because there is the audience is big, the objective is different. If you are very comfortable with Terraform, you don't want to spend some time setting up that, then you can skip that. But preferred approach is Terraform. You can destroy it with one command. It will save you some money and will definitely add to your learning as well.
Great. Okay. Thanks for that. So the other question is is connected one, like the demo session, what we had today, it's more like a informational, if we understood it correctly, that this is what we are going to achieve it, right? So from the next session onwards, now that we are 1 week and we finalized what tool, what technologies we are using to run those things, and there will be a demo session how we are going to do it, because the audience is huge.
Yep.
Maybe you might not be able to take each of the doubt classes during the live class. So how we are going to address these questions in future?
So there are 2 or 3 ways we will be collaborating. It's through that WhatsApp group. I am assuming a lot of people are going to choose AWS and focus on that side. If all of us are focusing and starting at same point, next week somebody will achieve it, so he will be able to guide. I am there, Saurabh is there, a lot of people are there in that group to help. If people are stuck, try to do your analysis, try to do your setup. That's the one way. In the subsequent sessions, it's entirely up to us how we want to do it. I can do a live demonstration how I have done it in my environment. We can, in the July batch, we had a lot of and the folks are in this project as well. If people achieve something, they will announce it in the group that yes, I'm able to set up a cluster using Terraform, and I'm going to demonstrate that next week. So we do that kind of demonstrations as well.
Okay, great. So the WhatsApp group which you are talking about, I see that is only for admin. So we
That
will
is
be
right now.
getting the rights, right?
Right now it's for admin, the August
Okay.
batch, but I will open it for everyone.
Great. Okay.
But there is, I forgot to mention, I will open it up, but just a request that don't forward anything useless which is not relevant to the project. I understand that, I forgot to mention it in that WhatsApp slide where we had that group. And more questions are coming already. Try to be mindful that working professionals are there in that group and send sensible information and not any forwards, and have your specific questions, not like it's not working for me. That's not the way. What you have done, any logs, any specific error you are getting, highlight that error, that this is the error that I believe is the main cause. Can somebody look into it?
Makes
That
sense. Completely makes sense. Yeah. And probably the last one from my side for today, the amount of work we are going to do in next 4 to 6 weeks, do we have a already recorded session, or maybe a recorded session you might record it in future and then provide it before the end of the course, so that at least we would be having that these are the steps you probably followed, and then we can mirror them if we are stuck somewhere and the classes are over, we still have something in our hand to follow it.
Right. So what I'm expecting is how it will go is there is nothing we have recorded as of now. It's going to be all live. So whether I demonstrate it to you, the solution, or the learners or whoever is able to achieve it, they demonstrate it. They share their public repository. It's going to be through demos, through building that solution. So it's going to be recorded as we go, and at the end of it, I have more slides to talk. Should we just do for this week and then discuss the phase 2 and phase 3 parts, or should we continue today? But to answer your question, yes, the things will be recorded. At the end of the session, we'll summarize everything what we have done. We will have the GitHub repositories that we have built for this project, and we will share it to you. We don't want to do it right away, because then that you are going to refer those repositories and get very biased and not do your own hands-on. So that's why we want to give you a playground, give you a direction that you follow this, and you just try to do it in your environments.
Perfect. Thank you so much.
Otherwise, I give you something EKS specific. people are there who want to do it on Azure and GCP, and they will be feel left out. They will create a not a very level field. So now with this approach, you try it in any environment.
Hello, Sanjeev.
Yeah, hi.
Yeah. Am I audible?
Yes.
Yeah. So while discussing about the project, you just mentioned like setting up Kubernetes cluster on AWS resources. So can we use default VPC as well for deployments of worker nodes?
Yes, we can.
Like not creating our own VPC, because it's obvious like it is chargeable, like creating another VPC that I
VPC,
was aware of.
VPC, there are no charges for creating another VPC. But
Oh.
if you think internet gateway or any such resource you are likely to be charged, you can avoid that. You can always do it in the default VPC as well.
Okay. One more question, Sanjeev. I am from electrical background, and I have just spent a couple 3 to 4 months learning the DevOps terminologies and tools. So, what are the challenges? And like I have also done some projects like CI/CD project and Kubernetes project as well, like deployment of a simple web application on Minikube cluster like this. But once I applied for the job purpose, so at that time, like I got a assignment from the uh, employee of the company. So at that time, the major problem what I faced is like they give me a GitHub project, like application, web application that to be deployed on Kubernetes cluster, and to do all this thing that you discuss in the project, like monitoring and how you will choose a proper tool to configure and all this thing. So
Right.
what are the major problem I came across? Like I just, as I mentioned, I from electrical background, that don't have just more knowledge on development side, right? But I have just gained the flow of how the DevOps terminology works, right? So main problem I face is like just I got the GitHub repository of the project by the client. So the major problem I face that how to what should my mindset to like to how to just get started the things, and in this area I am just suffering.
Don't worry. That's the exactly same approach we are going to follow. We are going to give you 2 repositories. You can again pick and choose based on your use case. We'll give you 2 repositories that you have to deploy in Kubernetes cluster. We'll guide you how to do it, tell you what steps have to be followed. First step is obviously week 1, setting up the cluster. And then next is we have those repositories ready, which you will be deploying. So if you have done that sort of activity, it will be much more easier for you to do it for any interview task that you are given.
Yes.
But what they expect is follow those best practices, integrate with the right tools. That is what they are going to talk about, view in the solution that you are going to present to them.
Okay. And one more thing, like in starting, you just mentioned that we can use this project as experience, like 5 to 6 months experience we can showcase in our resume or in LinkedIn or social platforms. So what if the interviewer asked me like, if you have any proof regarding this, like you have worked with this XYZ company, in that scenario, what we can do?
So I have briefly talked about it. If, for example, it's that showing that experience case is relevant, if, for example, you are working for an employer where you don't have to justify your salary slips and your the actual working. So, for example, you are working for a bank, or you are working with the company called TCS, Infosys, anywhere, but you are working for another client of yours, which is not using Kubernetes. In those scenarios, it is very much possible, and a lot of people do it. There is no shame, and people don't get to work on Kubernetes environment. So in those scenarios, you can justify that you are working for this bank. You are not working in Kubernetes, but because you have worked in this project, you are comfortable talking about Kubernetes. The role require that knowledge. You can say that you are working in this area, in this project. Then you don't have to give any proof. If somebody is not working in any company and then want to use this, then they need a lot of other things to be proved.
Okay. And will you provide some sort of just certificate at the end of completion of this project?
Yes. So a certificate will be provided, but it will be a project completion certificate. It's not an experience certificate. It's not you can't say that it will not be a bank, or it will not be an organization kind of. It will be a small company that we have. It will be a certificate from there. So it's entirely up to you how you project that, how your new employer takes it, because we are not giving an experience letter as such, because experience letter has to be backed with salary slips and has to be backed with other financial stuff, which we are not going to manage. But yes, you can use this certificate to showcase that you are an intern or unpaid kind of thing.
Okay, thank you. That's all from my side.
Hi Sanjeev, this is Karthik here.
Yeah, hello. Hi, Karthik.
Yeah, just have a quick question on this commands for reference. I'm thinking like to use a Minikube for my for this project.
Yep.
So is this config file won't be the same, right? What sort of information does it have? This config file has. I just want.
So if you are going to use Minikube, then command number 1 and 2 are not relevant for you. Those are EKS specific. Minikube, what happens is once you install Minikube, then automatically it will download the kube config for you, and you just need to download the kubectl, which is command number 3, and you are good to go.
Okay, so this week, the first week of this project is to installation of the packages, right?
Yes. The installation of these tools, so you can interact with your cluster. You can do like basic get nodes, get pods, basic stuff. We're not going to deploy something, but we will have the dashboard and tree integration tested, those basic stuff. So you get a little bit comfortable with cluster as well.
Okay, so we are not deploying any of the pods for this week.
Any pods that we have built or that our project requires, which we will talk about later.
Okay, yeah. Thank you, Sanjay, for that answer.
Hi, Sanjeev. Hello. Sanjeev Fajaz here.
Hi.
Hello, sir. Sanjeev, just a question. Are we going to use any web servers to deploy our application and check?
Any web servers?
Yeah, I mean to like once the deployment is completed, are we going to deploy those two on web servers and check whether the application is working properly or not? Example like Tomcat servers in an Nginx.
Not Tomcat, not Nginx. It will be a full-fledged application that you will be able to see, interact with it. We will store some data. We will delete our cluster, and the data we should be able to retrieve the data also, like that kind of.
So you mean like it's gonna be a direct applications. We are not going to deploy those on a server, particular web servers or application servers.
Not like the way I'm guessing that you want to see it. It's not going to be that way. There are easy ways possible in the Kubernetes how you deploy your and expose your UI web application, and that's all.
Okay, and one more question, like are we going to interact some ticketing tools like in real time, like if the customers or any other team members like facing, they will raise a tickets. So like how we are going to use those ticketing systems and interact with the clients to work on the applications and Kubernetes things. Like are we going to use any ticketing systems to to just enhance on
No, we're not going to get into all those other complexities of other stuff. In fact, in our
Okay.
subsequent slide, I'll talk about even we will probably not do a lot of CI stuff also. This is mainly for hosting the application. This is a target for hosting your applications and databases. So we'll focus more on the deployment side of it. We will build
Okay,
and package and deploy our applications. That's why we are deploying the dashboards, deploying the tree package, a lot of things, mainly focusing on deployment, not even focus on CI part of it, because that's what we already covered in the July batch. And also you can build that knowledge yourself, because that's container building, packaging, that you
Okay.
can cover separately, because then it will
Like,
become a very complex thing.
Yeah, got it, got it. Just one, like at the end of the day, like just we can have a glance, like how we are going to, deploy on web servers and, check the application, like how it's gonna be work.
Absolutely. You
Is
will
it be
see that
fine?
application running, user interface, interacting with it.
No, I mean like through a web server or application server
Yep.
instead of, directly, checking application directly.
I think you are not, we'll get into that. Don't worry.
Okay, no issues.
We
Okay,
will
yeah,
get
thank you.
into
Thanks
all.
so much.
Don't worry. There you will
Hi,
get.
Sanjeev.
Yeah, hi.
Hi, Pradeep this side. So, Sanjeev, I had 4 questions that two you have already answered during the session.
Okay.
So two left. So like when we will set up all the things, okay, then we will have a scenario where we will be upgrading the cluster. Like after the setup, will we doing the upgrade
We will
cluster
not
upgrade?
do that. We will not cover upgrading in this project as such. But if you want, we can
Okay.
enhance the day two side of it. We can look at upgrade process as well. The issue
Okay.
is the
And
minor
the second
upgrades. You may
thing,
not face major issues. Organizations that upgrade
okay,
from latest version to another recent version may not face those many issues. It's when you have used a specific version for few months, few years, that's when things start to
okay,
break very quickly.
okay, thank you. And the second one is like the scenario where we have multiple microservices and running on multiple nodes and multiple pods, and how they are interacting with each other.
Correct.
We will be covering this part.
Yes, I think what we should do is we should cover that. This is not the end of this session. We should move further, because a lot of questions are we going to do this? Are we going to do that? Kind of questions.
Okay.
Let's take a 2 minutes
Okay.
break, not more than 2 minutes, and come back. And
Sir, I have one question, sir. Hello.
yeah,
Sir, actually, not about this project, sir. So, July batch I have not taken as a direct candidate like this, but I have purchased with half amount, sir. So the
okay.
thing is that I was able to understand the first video, but unable to process, sir. In middle, I have some doubts. So, is there any possibility to send PDFs for me, sir?
PDF
So
is
what are
possible,
the
yeah. You can. Everyone has the PDF.
for us? We got only videos, sir.
You ask in the WhatsApp group. The problem with WhatsApp is that the history is lost. So if you join today, the historical things will not be there. You ask me on WhatsApp, I will share you the PDF. This PDF that I am discussing right now, I will post it in the WhatsApp group.
Okay, sir. Okay, sir. Thank you.
All right.
Hi, Sanjeev. This is
Sanjeev, don't
Sudesh.
say sir, so that looks very.
Hi, Sanjeev. This is Sudesh. Had one question if you have got time.
Yeah.
So regarding the cluster configuration, so we are talking about cluster configuration first, and then we will proceed with the application deployment and then setting up monitoring and dashboard. So regarding the configuration of cluster, are we going to focus on the security aspects of it also, like TLS, SSL, cert manager, also like secret manager? You already mentioned secrets. So are we going to use any external secret manager like they are used in
Secret manager, yes. Secret manager, yes, but not so much into all other areas that you mentioned.
Okay. All right. Okay.
But
Thanks.
it will go very, very complex. Like this is you can treat it as a starting point for your Kubernetes journey. The actual Kubernetes learning and the process is much more lengthier. There are so many options and so many possibilities in this framework and platform. It's probably a 6 months kind of project or 6 months kind of learning curve that's required. But
Okay.
by doing this project, you will get started on that.
Okay. Thanks. That answers my question. Thanks.
But again, do remind me on the batch in the WhatsApp, any topic that you want me to bring. But after we finish this, like once we have achieved 2 or 3 weeks of success, then remind me. We can bring that. Last batch requested that they want to do a mock sessions or something, like we ask some interview questions based on that. So that sort of thing we are doing for the July batch next week.
Yeah, I saw that on the YouTube videos.
Yeah. So I'm preparing those random questions, and whoever joins, I will be asking that what you have learned from that project, and some random difficult question. Let's see how that goes. Will try to bring that kind of environment, but do remind me if any specific thing you want me to bring.
Sure. Thanks.
All right. So I don't intend to finish this quickly. I don't know what time it is. We have spent a lot of time. So how do we do? I have more slides to go. Can we take 2 minutes break and come back? And what we will do is we will talk about the subsequent weeks and quickly run through those slides, and then do a revisit them in the next weeks as well. So just to give you an idea, what we want to do in the subsequent weeks as well. I'll just quickly run through it, not spend a lot of time, because the PDF anyway is going to be shared with you. So you shouldn't feel that there's information which is not making sense. So let's do it. Let's not even take a break. Let's do it. These are the 2 repositories on your screen, which we will do after week 1. There is a retail store sample app, which is a public repository. Then in the July batch, we did a pet clinic app, which is used by all the demonstrations and all. It has a database component. The idea is that we will install this application in the cluster, which has a MySQL database, etc., and the user interface. We will follow the ArgoCD GitOps approach. Why we follow ArgoCD and why this is relevant for this? If you look at, you can do this through Jenkins also. You can install, for example, this very poorly designed deployment process installs a kubectl onto Jenkins machine, which has the credentials stored for your Kubernetes cluster, and it talks to the API server and pulls the Docker images from the registry and installs on the worker nodes. That's how this setup operates. A lot of issues. You need to install kubectl on Jenkins. You need to provide Jenkins your cloud access. You need to provide Jenkins the access to your cluster. So somebody doesn't have to hack your Kubernetes cluster. They have to just hack your Jenkins environment. If they have access to your Jenkins, they have access to everything that you have in Kubernetes cluster. So very poor design. It increases the attack surface area immensely. It adds more tools and scenarios in your environment, which can be compromised. And the problem with kubectl is that once it has deployed something, it does not have the visibility. It doesn't know whether is the deployment successful. If the container was unhealthy, what to do next, and anything changes in Git repository, it doesn't know what to do and what was the state of the environment. It fires a command. It's like a fire and forget kind of deployment. You do a deployment, maybe a DevOps engineer will monitor it for you, but was that successful or not? It doesn't know. And the rollbacks are manual. There is no way for Jenkins to know what the state it is. And if you have to do a rollback, you have to delete the environment, you have to clean up yourself using kubectl, and you have to recreate it yourself. So these are some of the issues with Jenkins, Azure DevOps, GitLab, any other such tool doing the deployment on Kubernetes cluster. So Kubernetes cluster has its own way of managing the deployments. So what that approach is, that you have some code repository. Jenkins will build the pipe, will have some build process, which will create the Docker images. So in the subsequent weeks, we will do is, we will take these Git repositories that we have, and we will first containerize them. July batch people have done that activity, but you can do that. It's very straightforward. They can also provide you Docker file and all. So we will push that image into Docker registry. Then there will be a second layer of repository, which will store some information about how that Docker image has to be deployed, which will be the ownership of the DevOps engineer or the cloud engineer. And the ArgoCD component, which is actually sitting inside your Kubernetes cluster, is going to be looking for any changes to that GitOps repository. It's nothing but another Git repository, but it has the configuration of your environment. You have to use this Docker image, this tag, these many replicas, these many pods have to be created, that sort of thing. And if you upgrade, for example, from version 1 to 2, the DevOps engineer will update this repository, and ArgoCD will identify that there is a change, and it will automatically update all your clusters on your right-hand side. And because ArgoCD is inside your cluster already, there is no compromise. There is no increase in the attack surface area for your environment. So this is the approach, which is the GitOps approach, where your configurations are also in the repository, and ArgoCD, or there are other tools. ArgoCD is just not GitOps, right? GitOps is an approach. ArgoCD fulfills that approach. It looks for changes on your Git repository and applies to your environment. There are Flux and there are other such tools as well. So this is what we're gonna do. We wanted to now start looking at deploying our stuff into the environment. So we want to look at how, because this is the complex part of the cluster, and this is where people struggle. This is where the complexity is, because everything we have seen, cloud manages things. You can have auto scaling and all, but this is where you have to write a lot of manifest files, a lot of configuration files with hand, and that's where it starts to get complicated. So we will look at what a deployment is. A replica set, you need 3 such containers. A pod with the label of front end gets created. So you need this sort of thing, this sort of file, which you can then use kubectl to apply in your development and testing environment. But you will put it into Git repository, and your ArgoCD will pick it up. So we will probably revisit this in the next week. There are like 10 or 15 different type of resources in Kubernetes. If you understand those resources and you are able to write those files, like for example, a secret on your left-hand side that's how you define a secret. Then that's how you define a PVC in your environment. And then in the middle, you have a replica set being deployed, which refers to this persistent volume claim that we have created, and also refers to the secrets that we have created. So the one in the middle refers this and this. Similarly, HPA, which is auto scaling feature within Kubernetes, that refers this replica set, and it says that if your CPU utilization is above this range, then what should you do? You can go to more replicas if you want to. So it will automatically create those additional replicas. And then exposing your container as a service. So somebody was asking, do we do Tomcat and all? We just create this kind of service object and deploy that in the cluster. This is connected to your my app, which is this application based on the label, and that's how it flows. So this is where it gets complex. This is what we will look in week 2, next week onwards. Already I have some commands how we can deploy ArgoCD inside your cluster. So it's not like Jenkins, which is sitting outside, but it is within the cluster. Then we look at the a sort of logical view of our application, that pet clinic application that we are going to deploy. We have some front-end pods. We have a replica set created for that with two pods. We will write something for deploy, something for service. Similarly, the other database side of it, database will need some sort of storage. So we will create storage objects. We will write these files by hand, practice these things, because this is where the crux, for a DevOps and cloud engineer has to focus on. And then that will be exposed as a service. So now when the front-end pod has to refer, database should be available first. So the database has to be ready, then this pod has to be created. So we will put all these configurations in the repository, which Kubernetes will automatically ensure that first the database will be up, then the front end will refer to the service exposed by database, will refer to the secret that a database created using the username, password, and the service endpoint. This will be able to connect. And then we will do other additional things. We will terminate all these pods, but the data should be still persisted, do all those disaster recovery kind of things. That is the plan. I have already given high-level steps that have to be followed. How you have to containerize the pet clinic app. You have to push it to your Docker images to the registry. You have to set up the Kubernetes cluster. We have to create deployment manifest files that we talked about. So that's where we'll ask you to do it, or we will give you a repository where you can refer it. Create the services for your database and deploy the app. So those are the high-level steps that I will share, and then I'll explain it maybe in the next week. Then we will go into more deployment strategies. Once you have deployed a specific version of the microservice, your development team is going to upgrade that, how those rolling updates have to happen, what is the max unavailable that you can afford. You have 3 replicas, you have 3 containers running. In the rolling update, you don't terminate everything, because your application remains live in this. There is no downtime associated. So you will replace one pod every 10 seconds or that kind of rolling update. Then there is a recreate process where it will terminate everything right away and will recreate those environments for you. So we will test these strategies, different deployment strategies, very common in the interview. What deployment strategy did you follow? So I have put together these, like how the secrets have to be managed, requirements for our application build and deployment. We will not do a lot of CI/CD, not do security of our Docker images, and that's beyond like easier concepts. We did that in the last project also, but if we start doing a lot of CI/CD sort of things, DevSecOps in this, then the project scope becomes very massive. Then the last week, we get into the monitoring and observability side of it. We'll not talk about this. This I got something from internet last week, so we'll see how it goes. This is how the tentative schedule that I have planned for this. Week 1, default cluster. Your cluster is ready where you can work. Understand the terminology of Kubernetes, integrate with tree and delete the integration. We will not carry on with the tree integration because it prevents us playing with our unsecure images and playing around with, in our dev environment. You have a dashboard in place. Make sure your dashboard is being, you have implemented. If you struggle, WhatsApp group is there. We are there. We will, work together and try to resolve this. And you get good understanding of the terms. What is a replica set? What is a deployment? What is a pod? That understanding. You don't need to build anything as such, but if somebody is expert, somebody is advanced, they can definitely move on to week 2 or 3 kind of activities where we will start building the pet clinic application, start building the Docker image. We will start installing ArgoCD inside the cluster. I have already given the commands. Have a Helm chart created for the manifest that we create. So just like a dashboard is available to us as a Helm chart, we can expose or we can publish our own pet clinic application deployment Helm chart also. So we can start looking into that in the week 2 and 3. Rolling updates. And this is the main thing. Week 2 and 3, at the end of week 2 and 3, able to read any random deployment file when presented. So something like this. We will bring some random code for you, that this is the code, because that's where people struggle. They look at some random deployment files and they don't understand what it is and how these are integrated, or are they independent piece of code, or they are talking to each other. So at the end of week 3, the expectations are that if any random deployment file is presented to you, you should be able to tell that, oh, this is a secrets file. This will create a new secret. This is a service file. This will create a new service in the Kubernetes cluster. This will create a pod. This is a replica set, which will create 3 pods with rolling updates and something like that. So that is the level of skill set we want to reach at the end of 3 weeks. This will only be possible if you focus on week 1 in detail. Then week 4 and 5, we will set up alerting and monitoring. That will be our focus as per industry best practices and standards. And in the week 5 and 6, we will summarize everything what we have learned. We'll do a lot of demos. If you are not able to achieve within our group, anyone is able to achieve those demos. If nobody is able to achieve, we will bring our own demos, our own repositories. Some of the advanced stuff which we are not able to finish in this limited time, because we are learning curve as well, and we will still guide you that as a next stage what you should learn, where you should build your next sort of skill set within Kubernetes. It's a 5 to 6 months kind of learning curve for the entire thing. Mock random interview questions, and then eventually how do you build that story, that if you're planning to use this as a 6 months kind of project, what should be your language? That yes, I implement a production grade Kubernetes cluster for customer X, and these are the steps that I followed. So that story we will try to guide you, that how you can talk about that in your interviews, and how you can specify that language, what language should be spoken about this project, based on if you just do this project, how you use that as a 6 months experience. Okay, final deliverable. People have been asking, we need certificate, we need all this. So we request that you finish your project, focus on that. Don't focus on certificate alone. Certificates are possible through different channels. The final deliverable, we expect you to build it on your GitHub repository. Do a short video so that we can publish it on your YouTube channel. We can have other people getting help as well in future, that this was the project, this is how this got implemented, and this just helps us putting a lot of content for people. Not everybody can pay and join such projects, and it will help everyone. So we'll get into all this, not something to worry about this. So a lot of plan we have to make it a good learning curve for everyone, and ensuring that we are following all possible good standards, and you can justify as a sort of experience for 2-3 years, 6 months kind of experience.
So
All
Sanjeev,
right.
we talked about this a lot, regarding July batch. So is it a series where people, I'm sure many of us haven't attended this July batch.
Yeah.
So do we really need to cover that one first and then switch
No,
over to this
no,
one? Nothing related to it,
it's
right?
not
Okay.
required. So
Okay.
that was the same pet clinic repository was used there, but we did not touch Kubernetes there. We deployed that container on an EC2 instance. That was a different use case, different environment. So if somebody is interested in DevOps, Terraform on and securing your VPC in AWS, or securing your VNet in Azure, you can take a look at that project, but that is an entirely different project. This is just that we use the Pet Clinic app as well there as well.
Okay.
Hi,
And
Sandeep, can I?
I'm sorry, just a quick one. So, Sanjeev, you mentioned about that Jenkins we are not using. We are using ArgoCD to, communicate with
Right.
that Kubernetes cluster directly. In Jenkins also, I mean, you can correct my understanding. In Jenkins also, we can use some secrets, or we have HashiCorp secret vault. Those things we can still use in Jenkins and communicate secretly with Kubernetes, right? Then, yeah.
Yes, we can, but it's an external component. You need to
Okay.
provide those secrets to Jenkins. So
Mhm.
if your Jenkins is exposed, your entire cluster is exposed. That
Okay.
is one
Okay. Makes
central
sense.
failure point. Then second is it will use kubectl to deploy. So you will, for example, you will say a pod specification and use kubectl to deploy, which is not very standard way. Like it doesn't know, it's a fire and forget kind of thing. You say deploy this, Jenkins will say, okay, I fired this command. I don't know what happened thereafter.
Okay. Okay. So instead of Jenkins, can we use Ansible there? No.
Not for like this. For Kubernetes, it's better to follow a GitOps approach where you are pulling the information from your Git repository from within your cluster.
Okay.
That
Thanks.
has immense benefits. That has not just the deployment. It's, for example, your entire cluster crashes, or AWS region is crashed or not able to communicate with it. You can just from your code repository, you can create a new EKS cluster in a different region, install ArgoCD inside the cluster, and point it to this Git repository. Your entire cluster is going to be, you can stand up in few minutes.
All right. Thank you.
With
Thanks.
kubectl and all, you will have to do a lot of deployment stages, fire those commands and document them, and hope that everything runs in sequence and everything runs fine. With this approach, if ArgoCD is not able to deploy something because there are not enough resources and all, it will keep trying. It will keep trying, and that is the benefit, that your deployment submitted to it, as soon as a resource is available to it, it will finish that deployment. So that brain is with ArgoCD, that it has to bring the entire cluster into a desired state.
Okay. Okay. Makes sense. Yep. Thanks, Sanjeev.
Hi, Sandeep. One question. Like you can correct me and guide me. I just know all the basics commands. I know deployment, service, and all. Like as Saurabh said that if I going to use EKS, so there will be a master, and I don't need to create any EC2 instances. I just have to configure, and it will automatically scale up. So like I normally use my laptop's WSL to connect to any EC2 instance. So here in EKS, how can I connect to like the master node? Like you can like guide me to see some videos or something like that. So where can I run the
Why do you have to connect to the master node?
like I'm asking that because where should I create my deployment files and service YAML files?
In your
Where should I do that?
repository, you will create those files in your personal Git repository, and
Okay.
then use ArgoCD, or for temporary, like your ArgoCD is not ready and you want to deploy, you can use kubectl to deploy your files.
Okay, for first week, what should I do? Like I configured an EKS. So to get the dashboard, I need some terminal.
Yes. Use your
so how-
WSL terminal. Use your WSL terminal that you are talking about. Install kubectl there and talk to your cluster that get me the pods, get me the nodes that are associated with the cluster. Just reach
Okay,
to
so
that.
I just need to see that how to connect EKS cluster to terminal.
Yes.
That thing I just need to see, right?
Exactly. And
Okay.
your terminal will have kubectl and the kubeconfig file for your cluster, and that's how you will be able to talk to it.
Okay. Thank you, sir.
And your kubectl talks to your control plane API server.
Yeah.
So that's why I said you don't need to understand how it works, how behind the scene API server works, but it talks to the API server. That's where you talk to. Not directly the EC2 instance. EC2 instance of the control plane is managed by AWS. It is in the AWS environment.
Okay. Thank you, Sandeep.
Hi, Sanjeev.
Hello.
Sanjeev, I have a quick question. I just wanted to understand what's the industry standard. For example, we fire a Terraform apply command, right? So does it happen through the Visual Code or WSL, or in the industry, do they use a Bastion server to fire it from?
Not yeah. Again, it's a slightly debatable thing. In our July batch, we did was, and what I have seen myself, we don't use Bastion hosts and Bastion servers. They are again security risk. Somebody has to get connected with your Bastion host, and that's your big security issue, because that has access to everything from there onwards.
Right.
So there are other ways in AWS. There are EC2 Connects, a new service launched, and AWS SSM service, where you don't open your instances. Your private instances remain private. You don't open port 22 for them, and you connect to SSM. So that was the accomplishment in the previous batch. Somehow it references to previous batch. But that's where we try to do a lot of secure stuff. We don't use Bastion hosts.
I see. Because the reason why I asked is from whatever videos I have gone through, right? So they ask you to create a service account, and then using the AWS configure, you put your credentials, and then you fire the Terraform command. Correct. So that's something I feel is not quite secure. So
that's what there will be a lot of shortcuts there. You claiming those are short videos. A lot of things are pre-packaged, predefined for you. So which is good that you are going further and trying to understand what happens in the industry. So a lot of things are going to be publics, not going to be in public subnet. They are going to be in private subnet. Even I have seen, like, even though there is no concept of a secure subnet, in the previous month, we put our database in the secure subnet, which is the internet can't reach that, or that level of security. Like, you have public, private, and we have secure. Only private subnets will be able to talk to secure subnet. So we did next level. So there the focus was different in that project, building secure, reliable infrastructure, and also deploying the pet clinic in an auto-scaling group, using CI/CD, using DevSecOps tools. So that was entirely different area. This is entirely Kubernetes stuff. So we don't want to focus on basic of Jenkins or that sort of tool.
Okay, got it. Thank you.
I'll take some questions from the chat. I don't think 1 month will be enough for this project. I think it will take 1.5 months. That's absolutely fine. I'm not in a hurry. I'm not starting any new batch or new any stuff. As I mentioned, if this has to be successful, you guys have to be successful. You need to be able to build it. So if it takes 1.5 months, let's do it. If it takes 2 months, let's wait. And the WhatsApp group is there. We all are there. That's the whole idea, right? We are learning in a group. Everything should move forward. Everybody should learn. And once they are comfortable, once they have built it, then we move on to the next stage. The drawback is some people will do it much quickly. So we have to find a balance. We can't drag it like 6 months kind of thing, because some of the people will finish it as well. So as soon as we have 1 or 2 success stories coming up, we will start doing demonstrations and use that information, join the future sessions. And if somebody has done it based on their demonstration, try to quickly finish that project. Dinesh, you have some question?
Yeah, hi Sanjay. Dinesh from July batch. So, Sanjay, I have this question since quite a long time. You know, when we are using the Kubernetes secret component, we are anyway using it as a base64 encoded format. That is not the final thing, right? It is not encrypted.
Correct.
So for that reason, we use the third-party tools like HashiCorp and Ansible Vault for that. So why should we still use secret component? Is my question.
So this is again just to avoid the complexity of bringing another tool which is commercial tool and paid tool. So it's hard to bring all the concepts. So we will start with this. Obviously, we will target to use an AWS specific secret manager and try to integrate with that, not set up another HashiCorp Vault or anything, another third-party tool.
So that is the only reason. But apart from that, in the industry real time, we have to use third party, right?
We have to.
That was the conclusion.
Yes. Vault is has some complexities associated, but Vault comes when there are some compliance requirements, or you want to make sure your secrets are actually stored somewhere else entirely. But we can always we should at least use the cloud provided secret manager in these projects. We should target that.
Got it. Yeah, clarified. Yeah. Thank you, Sanjay.
The default, that is the biggest drawback of Kubernetes. The secret
Kubernetes secrets.
The secret management is very poor. Basic decoding is not sufficient.
Correct. Yeah.
But it gets you started.
Yeah. Thank you.
Abhishek, really looking forward to getting started learning Kubernetes and implementing this project, working together. Think we will definitely manage to. Definitely, we will make sure that everybody goes across the line. We can mention Terraform commands in YAML files of RCI/CD tool. Jenkins Azure DevOps. I'm not sure the context, Harshit, but yeah, we can. But again, using Terraform to create the cluster is not our focus in this project. It's more to enhance our Kubernetes vocabulary. So it's entirely up to you. How you create cluster using Terraform or not using Terraform. Minikube may not support Terraform at all. So how is that going to be relevant? So that's not our main focus for this. But if you have time and you are building, working on that skill set, because this entire thing itself is going to take longer than 5-6 weeks. If we add Vault or add Terraform or add other complex situations, it will be difficult to finish, and that feeling of a bit of accomplishment will be missing. July batch videos are proprietary videos. We are not making it public yet. You need to join that. On YouTube, public videos all videos are not available. So even if somebody is from July batch, please try not to share those videos with the group. To connect to container registry, secret should should be there. I read many of us use Minikube. Shailendra has question. Any specific reason? Yes, we can install it on our laptop. It's very basic version to get started, and very like suitable for students and people who don't want to spend on the cloud resources. They can do, but there will be some gaps. Eventually, as I mentioned, one of the best practice is to use managed Kubernetes service. So Minikube will not offer you that, but it will be free. Rahul says, help me to complete this project. I understand things very slow. We will go slow. All right. I think it's too late. As I mentioned, it's past midnight in Sydney, and Saurabh must have, like, he would also have to go. So I will close the session now, and I will publish the recording tomorrow morning. Don't expect anything today. Tomorrow morning, recording and the PDF file will be available in the WhatsApp group, and I will open the WhatsApp group for everyone to talk to each other.
Hello, Sanjeev. I just one question.
Yep.
For example, I set up a cluster in EKS, and then how to communicate, like I install Minikube in local laptop, yeah, otherwise create a new instance and then install in Minikube.
If you are going to install EKS, then you don't need Minikube. Minikube is a replacement of EKS if you don't want to pay cloud.
So how to like get my check like code is working, like how much, for
Okay.
example.
Let me share my screen. So, can you see my screen?
Yeah.
So you will install, say for example, you install your cluster with the name of DevOps Cloud Cluster. Say this is the name of your cluster in your region. Your region is, say, AP South. So you will run this command. The output of this command will be, it's assuming that you have set up your cluster. It will say that added new context for this this cluster to your kubeconfig file. So it automatically downloaded the secret for you and put it in your kubeconfig folder. And then you can install kubectl, and then you will download this, and then you can fire some command like kubectl get pods, get nodes, get all, get namespaces. And if that is successful, that means you are able to talk to your cluster using the secret that you downloaded and using the kubectl, talking to the API server. This will connect to the API server.
So generally, I run this install kubectl command in where actually?
In your local terminal on your laptop.
Okay, local. Okay, this config file is downloaded in my local system. Then
yes. So you see this example, this slide. This is your cluster. This is the API server where you are talking to the control plane of your EKS cluster using a laptop or a DevOps engineer machine with the kubectl. This, right?
Okay.
I know it can get very complicated very soon, but you will have to do a lot of research. You have to do, do some bit of get to an up to speed. 1 week is there, so utilize this one. Ask any questions, but try to do your own research also.
Okay, sure.
At the end of the day, can we get some example of requirements? So requirements come in different structure. I have put together requirements that you guys should meet in this project, and I couldn't go through them. So here are the some requirements. You can okay, sorry, I'm not sharing it, seems. So So yeah, this is how I put together some requirements, how it has to be. But yeah, the actual requirements and a lot of those things, other things like what container does and does not, will depend upon the container image that we are managing. Can we take help from ChatGPT, Bard if we are stuck somewhere? Yes, why not? We do it in the office, we do it all the time. Take it, but make sure that a lot of information that you will get from ChatGPT will be for older version of Kubernetes, and things break all the time. They may not work right away. Something generic, yes, you can take help. Please open the chat option in WhatsApp group. We will try to discuss or create another discussion group. Yes, yes, Bhaskar. I will open up. I was just trying to avoid a lot of messages before the project starts. So I will open up the WhatsApp group right away. But keep the messages to relevant, meaningful, low number. If somebody is helping you, do a one-on-one discussion as well. And yeah, create a subgroup for Azure fans if you want to, because that way you can take that conversation outside. That will be really helpful. Otherwise, it will be very messy. 100 people are there and you won't know, the right people will not get the help. So,
but Sanjeev, how will you understand that how many people are interested with that during the first week of it? If you can open the chat and people can opt for it and then, you know, have a separate group aligned with that.
Correct. Exactly. That is the idea. I will open it.
All right.
Yeah.
Okay. Thanks.
Purva, can we share point-wise what approach to follow? Purva, I have given quite a detailed discussion what has to be done. What is missing, like point-wise approach means that's what I have explained what we need to do in the next week. Set up the cluster, set up the tree integration, set up a dashboard, and a lot of these things are available. Like some commands are there in this document, and you can research and find out some of these things, and then get an understanding of the different Kubernetes resources, pod, theoretical, not build, not deploy anything. Don't do that. Just so that next week when we talk, you understand it. All right, guys. We can take rest of the conversation offline in the WhatsApp group, and then anyway we are rejoining next week. So I will publish the meeting links in the WhatsApp group going forward. All right, I'll put all this tomorrow, and I'll stop the recording.